Howdy everybody, and welcome back to the Mega Man tutorial. So last time we worked on unifying all of our states so that we could move, shoot, climb, jump, and shoot in all of those instances with seamless capability. Looks like I left some code in here that I wasn't going to share yet. Skip out of that for the moment. So anyways, what's our next goal? Well, Mega Man still has several more states that we need to introduce to his character. But, let's see, these states are the damage state, the teleporting state, and the death state. There is a theme that goes along with all of those, and that theme is you have to actually have some enemies in order to trigger all of those states. So today we are going to work on adding enemies to our game. So let's get cracking. So come on down over to your objects, over to your parent objects here. Let me open it up on my side as well. We are going to create a new object, and we're going to call it parent_enemy. Open it up, make it create, and we're also going to make a other views outside view 0, similar to how we did it with the Buster Bullet. We want to be able to give our enemies some basic unified information so that when we create them they don't crash if for some reason we forgot to set these variables. So HP underscore is equal to 1 and damage underscore is equal to 1. That's it. It's fairly simple. And outside view, instance underscore destroy. So if our enemy leaves our plane of sight, then destroy it. And I think that's how it works in the Mega Man 2. I tested it quite thoroughly, and it seems that the enemies are all destroyed as soon as they go outside of the room, outside of your view. So anyways, that's all we need to do there for the moment. Let's close all these other objects. Now let's start with some enemies. So to get us started here, we want to create the bat. So let's come over to our enemy objects group. So far we just have this woodman thing which we're using for a display. So let's add a new group. We're going to call this the bat group. And in there, create an object underscore bat. And we're also going to want another one, object underscore bat underscore spawner. For the bat spawner, we want to come over here, give it a sprite. Just give it the same sprite that we use for the camera. Since it's centered, it allows us to see where we're adding it into the room better. And you'll recognize this spawner's code from the Chip and Dale tutorial. We use pretty much the same code. So instance underscore is equal to no one. This variable is when a spawner spawns an enemy, it's assigned that enemy's ID. That way the enemy is, let me zoom in here now that we got all this stuff. It's assigned the enemy's ID so it knows that there is a spawned enemy in the room and that it should not spawn another enemy until at such time that that original spawned enemy dies. And come over here, we want to give it a step event as well. Oh, we also need to go back to our parents. Make a parent underscore spawner object as well. And don't do anything with it. We're just making it as a reference object. And set it as the parent for this. There we go. Now for this, for the spawner, we want to say get the view's current position, the X and the Y position of our view 0, and if rectangle in rectangle, so if our spawning area is inside of the view, pull up that code bit. So where view underscore X gets our X position of our camera and the Y position of our camera. And if rectangle and rectangle, B box left, B box top, B box right, B box bottom. So the B box for this, if the rectangle created by this is inside of the rectangle created by the view, plus the view's width and the view's height, then if instance is equal to no one, then create a new instance of object bat. You can tell this is old code that I basically just copied and pasted because I haven't changed up the way the parentheses work in it. But if we are not in the view, then if instance does not equal no one, so if the spawner is not in view and there is a spawned enemy and that spawned enemy doesn't exist anymore, so it's been destroyed, then set my spawn instance to no one so we can spawn another bat when if the player were to come back to the previous position. And I don't know if I like this very much in games. Back in the NES time, it was alright, but nowadays it's definitely, you typically don't want to be doing this where you go and you can spawn new enemies unlimitedly, I think. Or maybe you do, I don't really know. It's just kind of the style for this type of game. Anyway, so that'll spawn us a bat. So now that we can spawn a bat, where did I put that object? There it is. Now we want to pull up in the bat object. Go to the create. And we're going to copy a bunch of code from the, first thing first. Actually, we're going to delete that event. I'm going to set it to have a parent. Parent enemy, and inherit the create event. So we inherit that damage and HP variables there. Then we are going to basically copy and paste a bunch of code from the player object, except we're going to slightly edit it. So we're going to give it some states, just like the player has states. The bat has the roost state, the follow state, and the rest state. It has animation, image speed, direction, scale, state. We'll set it off as being in the roost state to start. Animation underscore timer is equal to sec times random underscore range 1 to 3. The reason why we're doing this is because when a bat is created, it'll start roosted at the top of the stage, and then it'll have like a 1 to 3 second timer before it will drop down and start chasing the player. Target is equal to no one, so that'll become player eventually when in the next state. Damage is equal to 4. This is how much damage it actually does. Then we have our X inputs, Excel, friction, gravity, etc. And of course our sprite lookup table, which in this case we aren't given it the ability to do left or right or anything, so it's kind of completely worthless having this sprite lookup table there, but I did it anyways just to have a sort of consistency between the code of all of my moving objects. So let's see. We have the roost state and so on and so forth. So coming over to our step state, we'll just add this in real quick here. There's a second part to the step state we'll add in a bit. We have our state execution, just manual sprite change, event user, state, and manual sprite change, blah, blah, blah. Just copied from the player. So let's go to other user events. User event 0, 1, and 2. Give ourselves some states. And the code for these is fairly simple. So for the roost state, we aren't going to be doing much of anything at all. So this state is completely animation dependent, so I just kind of combined everything into here. So when it's roosting, all it does is count down the animation timer, and when it makes sure that the image speed is equal to 0, and once the animation timer is less than or equal to 0, so once the animation timer triggers, and if the player object exists, this is very important whenever you're doing something that tells you to follow an object or something, you have to make sure that you check to make sure the object exists before you do that. Otherwise you can have weird crashes. So if we've reached 0 and the player does exist, then set my image speed equal to 0.5. And once we hit frame 5, then set our state to follow and set on ground equal to false. So the bat is going to be kind of like, is going to have an on ground check like the player, except he's going to be checking to make sure if the ceiling is his ground instead of the ground being his ground. Let me see here. Animation hit frame 5. Oh yeah. We should probably give this bat a sprite or something. Or wait. Yeah. Enemies, bat idle. Though you don't really have to, because it sets its own sprites through this system. But the main thing I wanted to look up was open up the sprites, enemies, bat. There we go. And I somehow managed to ungroup it. There we go. So here we go. The bat is going 1, 2, 3, 4, 5. On the 5th frame, he'll have opened up his wings completely, at which point he disconnects from the ceiling and he's no longer roosted. So follow state. The bat is very nice and easy because he follows through everything. He has no collisions. He just moves X and Y. So he's very easy to control. But come back to everything here. So animation. Image speed is equal to animation speed, which as we set back here is 0.5, and we could do the same thing here, just animation speed at that point. In case you didn't know, this is the animation hit frame script right here. Collision is movement. Like I said, you just plus equal X speed and plus equal Y speed because there are no collisions. The bat moves without collisions. Y fractions, again, just normal Y fractions copied from the player. Acceleration is a bit different though, because now we are following the player object. determine if our X or Y axis is closer to the player, and subtract 16 because we want to aim for the player's head, not his feet. Because, as you remember, Mega Man's center is down here, and we want the bat to be aiming for this place right there. That's where we want it to attack. Length is equal to point distance, x, y, object player x, object player y. Yeah. So you might be wondering why I'm just checking for object player right here, and I don't have a check to make sure if the player exists. Well, I do have a check for that. It's right here. So we'll get to that in a second. So we check to see if the player object exists. Well, we check for his position, and we get a direction and a length, and then we get a length x and a length y to figure out what direction has the most distance between us and the player. So if the x direction is 16 and the y direction is 8, something like that. And then if our x direction is greater than our y direction, then move along the x-axis, give us acceleration in the x direction, and set our y speed equal to 0, so we're not going down. And if the and otherwise, if the x speed is less, then if the x distance is less, then x speed equals 0 and y speed equals this acceleration. So our max speed times the sine of the object player dot x minus x, which tells us what direction the player is in relation to our object. All right, and same thing for the y. So last but not least, then we come over to our states. We have our rest state. So when we're in the follow state, we can return to the rest state. So if the object player doesn't exist, and I don't think they actually did this in the Mega Man game, but I put it in there just because. But if the player, so back to the player object, you remember I had a variable that I set up in here called the last damager. So that variable lets us know who hit me last. So if the bat object was the last, if this bat object itself was the last one to hit the player object, then it will see that it was that its ID is is stored in that variable, and it will know to go into the rest state as well. So our x speed will be equal to 0. Set our state to rest and go to the rest state. If you don't, if you don't, you end up going diagonal. And I had a couple instances of the bats doing that before I remembered to set this into there. So number 3, rest state. And it's pretty much exactly like our follow state and everything else, except our acceleration is head to the ceiling at max speed times -2. So we're supposed to go 2 times the normal movement speed towards the ceiling. And fractions, ignore that. Collisions and movements. So we make it so we aren't checking for object-based collision because the bat doesn't collide with objects, but we are checking for tiles because if you remember, we have this ceiling up here which the bats are supposed to hit. And if you really wanted to make it super robust, you could actually make like another tile layer. Instead of using the collisions tile, you can make it like a bat roost level tile collision layer and use that. But I just felt like throwing it all into the same tile layer, so I did it this way. But once the bat hits that ceiling, then it will stop. So as we can see here, the image speed is equal to animation speed. P1 and P2, so that's left and right pixel of the B-box top of the bat object. We set on ground equal to true if either one of these have detected the collision tile. So coming back to our states, if we've finally gotten onto the ground, then set our image index equal to 0, so that we're at this frame. And our state to the roost state, and set our animation timer to 1 second, because that's how long it takes for the animation to end before you can go and attack again. And we're done. So that is a bat. Let's give it a try. Don't need you either. So if we come over into our room here, we can go over to my instance layer and bring in one of our spawners. Oh wait, I'm looking at the sprites. I always do that all the time. I'm looking at the sprites when I'm supposed to be looking at the objects. So our object, as you can see, it very nicely collides right there at the edge of our tile layer. So it's fairly easy to set it up where we want our bats to spawn. Yeah, right there. Let's give it a try. No crash so far. There's our bat. Now he's following us. Help! Oh wait, he does nothing. I am invincible! Ha ha ha! Enjoy my pet bat. Now let's see what happens. So as you can see, we can move past that, and we don't end up having multiple bats spawning because that bat is already there. But if we go far enough away, the bat disappears because he is now outside of the view, and we spawn a new bat. So now that we have that in there, let's take a look at our time. We are at 22 minutes, so I think we'll cut our episode short here. And next time we will get into damaging our bat object, and we'll look into creating some more enemies. I set up a lot of different enemies for this tutorial, so I hope you enjoy them all. Anyways, I think it's time for me to read off some Patreon names. So we would like to thank some people. Oops. I wanted to transition here. And nope, dang it. I completely missed everything. Alright, so I'd like to thank Fragile Hearts here, Crew Patreon, Damien, Kenneth Klein, John Dickey, and Vladimir Soldatov. Thank you very much for your support of the NES GameMaker. It makes it a lot more fun knowing that people are out there rooting for me. And if you want to become a Patreon too, just check down in the information box and you can find a link to my Patreon and where you can subscribe. We have $1, $5, or $20 tiers depending on what you want to get out of your subscription to my service. Thank you again, everybody. And remember, if you have a comment, please leave it behind. If you have a difficult problem that you need help solving, please let me know, and you can always join in on the Discord to ask us more questions as well. But until next time, good luck with your programming.